All right, buckle up, everybody, because today's deep dive is going to take us way back, like way, way back to ancient Greece.
Oh, yeah.
We're talking about Aristotle, specifically his work on generation and corruption,
Okay.
which sounds kind of ominous and intense, but really it's just Aristotle's way of tackling, well, those big questions like
Brass.
how does change happen?
What?
What is stuff actually made of? What are those fundamental building blocks?
Right.
Like, what are the elements?
Yeah, so this one's for anyone who's ever, like, looked up at the night sky and been like, what is all this stuff?
Yeah.
Or even, been fascinated by the idea of turning one thing into another.
Absolutely, like alchemy, that kind of stuff.
Yeah, exactly. So
It's like heady stuff.
it is. And it's amazing to think that these guys, way back then,
Yeah,
without all the tools and technology we have today,
right.
we're already wrestling with these, like, huge questions that still resonate, even today.
Yeah, it's like...
We're talking about the nature of reality here
Totally, yeah, and how things change and what they're made of.
and whether there's even nothing for something to come from.
Yeah, I mean, it's
deep.
a lot, and right off the bat, Aristotle just kind of throws us right into this debate
Oh, yeah.
that was already raging amongst philosophers back then about how does change actually work? It's kind of like,
What is the process?
yeah, are we just seeing things kind of rearranged?
Right.
Like, is it like shuffling a deck of cards, or is there like a more radical process happening where there's this
Right.
coming to be?
Yeah, like is something genuinely new popping up or is it just...
Yeah, it really makes you wonder,
Yeah.
like, if deep down, is the universe fundamentally static, or is it like
Right.
constantly in this state of flux and creation?
Yeah, it's a making novelty.
Yeah. So where did the ancient Greeks where did they land on this whole
We know, of course, you had different schools of thought,
right.
but you had the monists who believed that, everything comes from a single substance
Oh, okay.
and change was just like this superficial alteration.
So it's like everything is just water, but in different forms.
Yeah, imagine those who believed everything was water, just in different forms, different variations.
Okay, so it's like everything is just watery variations on a theme,
Yeah.
kind of a way to simplify things.
Exactly.
Yeah.
But then you have the pluralists, right, like Empedocles,
Okay.
who argue for the four elements:
Right, earth, air, fire, water.
earth, air, fire, water.
Yep.
Or thinkers like, Anaxagoras and Leucippus,
Okay.
who took it even further.
Okay.
They believed in even more fundamental components
Okay.
and insisted that there's a difference between coming to be and passing away.
Got it.
They're saying that change isn't just, reshuffling what's already here.
Right.
There's something else going on.
Right. So let's dive into some specifics here. Like, what were some of the the alternative ideas about what the universe is made of? Yeah.
I know Empedocles, he had those four elements.
He did. He did.
And he really liked to paint a picture, right?
Oh, yeah.
He describes the sun as everywhere bright to see and hot, the rain everywhere dark and cold.
He's very poetic.
Yeah.
It's almost like
Yes.
he's trying to capture the amazing diversity of the world.
Right. Right.
If everything just came from one single source, like how could we have
Right.
such different things existing alongside each other?
Yeah.
So he argues that these distinct elements with their own qualities
Right.
are kind of the answer.
Okay, and Anaxagoras had a different take, right?
Yeah.
He went even more granular, like with these things called homeomeries.
Right. So think of it this way. Like a sliver of bone is still bone,
Okay.
just like the whole skeleton is bone.
Right.
So he believed that, everything is made of these tiny ingredients.
Okay.
And no matter how small you break them down,
Right.
they keep their essential, boneness.
Or fleshness, or whatever it might be.
Okay, so it's like another way of grappling with that. Like, what is stuff really made of?
Exactly. Yeah.
Okay, now Aristotle wasn't one to just kind of sit back and be like, oh, yeah, that all sounds good.
Oh, no. No.
I imagine him, scrutinizing every detail.
Yeah, he was critical,
Yeah.
and he would, test the strengths of every argument.
Right, trying to find those, little inconsistencies.
Oh, yeah, absolutely.
Hidden assumptions.
Yeah, for example, he challenged Empedocles
Okay.
by asking, if your elements are truly fundamental,
Yeah.
how can they blend back together into, the single primal substance
Okay.
that Empedocles also believed in,
Right.
and then separate back out again?
Okay.
Doesn't that suggest that there's something even more basic underlying them?
It's like, hang on, you can't have it both ways. You're saying these are fundamental, but then also they can be broken down.
Exactly.
It's
fascinating, though, because this is like how science progresses as well.
Oh, interesting.
You know, you put forward a theory, you test it, you look for those weaknesses.
Right. It's like a process of refinement.
Exactly.
Yeah. Okay, so that brings us to this question that, like, still, I think, blows people's minds today.
Yeah.
The problem of infinite divisibility.
Oh, yes.
This is where things get
really interesting.
Yeah. So imagine taking a piece of matter and dividing it.
Yeah.
And dividing it again and again and again, infinitely.
Okay, yeah.
What are you left with?
Right.
It's like, what is there?
Is there anything left?
Yeah, so Aristotle spent
A lot of time.
yeah, like a good chunk of this work exploring this problem and all the paradoxes it creates.
Right.
It's like, it makes you question, like, everything.
Yeah.
You know?
It really challenges how we think about the world.
Totally. Yeah, it's like, if you keep cutting a cake in half forever,
Right.
do you eventually have nothing left?
Yeah, just empty space.
Yeah, or is there, like, this infinitesimally small cake crumb?
Or is there like a smallest possible piece of cake
Yeah.
that you can't divide any further?
It's wild.
So, you know, to kind of illustrate this abstract problem,
Okay.
Aristotle uses this very down-to-earth analogy, sawdust.
Okay.
You know, imagine sawing a piece of wood.
Right.
You keep dividing it smaller and smaller.
Yeah.
But eventually you get to a point
Boy.
where you don't have wood anymore.
Okay.
You have sawdust.
Right. It's fundamentally different.
It's different.
Yeah.
So is there a limit to how much you can divide something
Okay.
before you, like, fundamentally change its nature?
Right. So that's the question.
That's the question.
And that's where Democritus and Leucippus come in with their atomic theory.
Now we're talking.
Right.
These guys were, like, way ahead of their time.
Yeah, they were basically saying, what if everything,
Yeah.
from the hardest rock to the most fleeting cloud,
Yeah.
is made up of these tiny, indivisible particles, atoms.
Atoms, right?
Yeah.
And the variety we see, they're arguing, it comes from different arrangements and movements of these atoms.
Such a powerful idea.
Yeah.
Just imagine, like, different shapes and arrangements,
Yeah.
creating this tapestry of substances and change.
And they even suggested that color isn't an inherent property,
Right.
but like somehow produced by the turning of these.
The turning of these atomic figures.
Yeah, it's mind-blowing.
Yeah, of course. You know, this ancient atomic theory differs from, like, our modern understanding.
Cool.
But it's incredible how they're already grappling with these ideas
Yeah.
that are central to modern physics.
Right, but Aristotle ever...
Skeptic.
Yeah, he's like the philosophical detective, right?
Yes, always asking the tough questions.
So he wasn't completely sold on the atomic theory.
Right, he acknowledged some strengths.
Yeah.
But he had some major objections.
Well, yeah, of course.
Of course.
He's Aristotle.
He was pushing for, like, a deeper understanding.
A more complete explanation.
Right, like, he's questioning, okay, so if atoms just have shape,
Yeah.
then how can they have properties like hot and cold? Hard, soft. Like, wouldn't that imply some kind of change or interaction, you know, within the atom itself?
Yeah, it's like he's pointing out this, like, missing piece of the puzzle.
Right.
You know, if atoms are truly unchanging,
Right.
how do we explain these qualities
Yeah.
that clearly involve, like, a process or alteration?
Yeah, so he's like, I need a more complete explanation. Yeah.
A theory that accounts for all the evidence,
Yeah, exactly.
all the data.
Yeah. Yeah, it really is fascinating how these ancient philosophers were, like, wrestling with these really complicated questions about the nature of matter.
And they were.
But it wasn't just about, like, theory, right? They were also trying to, like, connect these ideas to the
world.
The actual, tangible world.
Yeah, the stuff we experience every day.
Around them. Like, how do you explain why some things feel hard and others soft? Why some things are hot and others are cold?
Exactly. It's like, how do you bridge that gap between the abstract philosophical concepts and, you know, the observable properties of the world?
Yeah.
And this is where, you know, some of those earlier theories like Democritus's atomism kind of started to show their limitations.
So if the only fundamental property of an atom is its shape, like Democritus argued, then how do you explain all these other qualities.
Exactly. It doesn't seem like enough to just say, well, the atoms in like a burning ember are arranged differently than the atoms in a block of ice.
Right.
It's like they really explain the difference between hot and cold.
It seems like there needs to be something more.
There needs to be something more.
Right.
And Aristotle saw this problem too.
Okay.
He insisted that these qualities, hot, cold, hard, soft, they imply some kind of change or interaction that, simple atomic arrangements can't fully explain.
Right. So he's pushing for like a more nuanced understanding of matter.
Yes.
And how these different substances kind of interact and relate to each other.
And how they act upon each other.
Yeah. Okay. And this leads him to
contact.
Yeah.
Which seems pretty straightforward, right?
Right. It's like
you touch something.
Yeah. I can't heat something up unless.
Right. Exactly. Unless you actually.
Punch it with something hot.
Yeah. Come into contact with it.
Okay.
But Aristotle takes it like a step further.
Right.
He points out that, contact, at least in the physical world, involves things having a position, being in a specific place.
All right.
And anything that has a position, he says, is also subject to forces like weight or lightness.
So he's connecting like the ability to interact physically to these ideas about place and movement.
All tied together.
Yeah. Right. Okay.
And this leads to some interesting discussions about how different things can act upon each other.
Okay.
So he distinguishes between things that impart motion by being moved themselves.
Okay. So like
imagine one billiard ball hitting another.
Right.
And things that impart motion while remaining motionless.
Okay, now that's interesting. So give me an example of something that can impart motion without actually moving.
Well, he uses the example of someone grieving us.
Okay.
Right.
Yeah.
They're not physically pushing or pulling us.
Right.
But their emotional state can still cause a change in us.
Yeah, that's a subtle point. But
it's powerful. It's powerful. And it's like he's showing that action isn't just about physical movement.
Exactly. It goes beyond that.
Yeah.
There are other kinds of forces at play.
Yeah. This gives me a whole new appreciation for the rigor and depth of this whole philosophical system.
These weren't just random musings. They were trying to build this
a coherent and comprehensive understanding
of the universe.
Absolutely.
Yeah.
And they were constantly challenging each other's ideas.
Right. Trying to really
pushing for greater clarity,
refine it,
consistency.
Yeah. And that reminds me of Democritus's take on action and passion, which he actually argued that the agent and the patient, the thing acting and the thing being acted upon, are essentially identical.
They're he says.
Which seems counterintuitive.
It does. Because how can something act upon itself?
Right, exactly.
If it's completely identical to itself.
It's like trying to lift yourself off the ground.
It's like bootstrapping.
Yeah, exactly. But he's basically proposing that things can only interact
if they share.
If they share some fundamental property.
Some fundamental identical property. Yeah.
It's a fascinating way to try to reconcile.
Yeah, to reconcile this idea of change with this principle that, it can't affect.
Right. Okay, but Aristotle,
as you might expect.
Yeah, not totally buying it.
Not entirely convinced.
No. So what's his?
Well, he countered.
Yeah.
By pointing out that, if things were truly identical in every respect.
Yeah.
There'd be no reason for them to interact at all.
Right. It'd be like
the universe would be static.
Yeah, static.
It's frozen.
Frozen. So change requires some degree of difference.
Yeah, it's tension.
Yeah, opposition to get things.
To get things moving.
It's like opposites attract.
Exactly. And this is where this concept of contraries becomes central to Aristotle's philosophy.
Right.
He argues that it's the interaction of these opposing forces.
Okay.
Hot and cold, wet and dry.
Yeah.
That, drives change in the world.
So it's like a cosmic dance?
It is. It's this push and pull between these fundamental opposites.
That's how the universe keeps things interesting.
That's how the universe keeps things interesting. Yeah.
Okay, I like it.
And you see this reflected in how he describes the elements.
Okay.
He believed they have this capacity for reciprocal action and passion.
Right.
So they can combine and transform into one another.
Right.
Creating this diversity of substances we see around us.
So it's not just a question of, okay, how many elements are there?
Right.
But also,
how do they relate?
Yeah.
How do they interact?
How do they change?
Yeah. Okay. And when it comes to the number of elements, Aristotle ultimately favored the idea of 4.
Okay, earth, air, fire, water.
Earth, air, fire, water.
Okay.
But he didn't just accept this blindly.
Right.
He, meticulously examined the arguments for and against.
He's got to be thorough.
Oh, yeah. He's showing that intellectual rigor we were talking about.
So, what were some of his objections to, other theories out there?
Well, he critiqued this idea of a single element as the basis for everything.
Right. Okay.
Arguing that it wouldn't allow for the kind of
change
and diversity that we observe.
Okay.
And he also pointed out the weaknesses of theories with too many elements.
Okay.
Or theories that fail to explain how the elements themselves come into being and pass away.
So he's like, I need a theory that is logically sound.
Yes.
But also
it's consistent.
Yeah, with what we see.
With the empirical evidence.
Yeah, he wasn't messing around.
No, he wasn't settling for half-baked explanations.
No, okay.
And this leads to one of his, I think, key insights about the role of matter in coming to be.
All right.
He argued that matter itself doesn't exist independently, but is always bound up with a contrariety.
A contrariety, so an opposing...
An opposing force or potential.
So it's not just
It's not just this shapeless...
inert stuff, just kind of...
Inert stuff waiting around to be molded into something.
Yeah, okay.
He challenged that idea.
Yeah.
He said, matter always has some inherent potential, some capacity for change and becoming.
Okay.
And it's through the interaction of these opposing forces that this potential is actualized.
So it's not just the ingredients, it's also about how they're
It's about the recipe.
Yeah, combined.
It's about the process.
The process.
And this brings us back to those 4 basic elements.
Okay.
And their characteristic qualities.
All right, so.
Hot and dry for fire. Hot and moist for air. Cold and moist for water. Cold and dry for earth.
Right. It almost sounds like one of those personality quizzes where it's
I know, right?
You're mostly fire with a touch of water.
Yeah, except this is about the fundamental...
This is about the universe.
Building blocks of the universe, not our individual temperaments.
Yeah, but there is a similar principle at play.
Right. The idea that
where
it's the interplay of these fundamental qualities that kind of shapes the character of everything.
Yeah. Okay.
But Aristotle wasn't content to just describe these qualities in the abstract.
Right.
He actually tried to explain, how they translate into the observable properties of different materials.
Right. What does it actually
mean for something to be hot or cold or wet or dry?
Okay.
So, for example, he explained that, water is readily adaptable in shape.
Okay.
Because of its moist quality.
Okay.
It flows and takes on the shape of its container.
Yeah.
And this makes it essential for the formation of compound bodies.
Okay.
Because it allows them to, have a definite outline.
Okay.
And hold together.
So water is the glue.
That's the binding agent.
Right.
That helps to bring the other elements together.
Okay. That makes sense.
And he went on to explain how the other qualities, hot, cold, dry, contribute to the properties of materials. So, he argued that the dry quality of earth contributes to its solidity.
Okay.
But it needs the moist quality of water to hold it together.
Kind of bind it all together.
Yeah. So even in this seemingly simple composition of the natural worlds, there's this incredible complexity, interplay of forces.
It's mind-blowing.
It is. And this leads to a rather surprising claim.
Okay.
By Aristotle, he believed that all compound bodies, everything that exists, in this terrestrial realm,
down here,
is composed of all 4 simple bodies.
Wait, so even things that don't seem to have any fire in them?
Yes.
I don't know, a rock?
Yes, even a rock.
Yeah.
So while each element is found, most abundantly in its own place.
Right, fire's up in the heavens?
Fire in the heavens, earth at the center.
Okay.
He argued that all 4 are present.
Okay.
In every compound body.
Even if it's in trace amounts?
Even if it's, in very small amounts.
Wow, so it's everything in the universe is kind of...
interconnected?
Yeah, at this fundamental level.
At the most basic level.
It's a very holistic view.
It is, and he even used the example of food to kind of support this idea.
Okay, how so?
Well, he pointed out that everything that grows, plants and animals is nourished by substances that are ultimately composed of these same 4 elements.
So we are what we eat.
In a sense, yeah.
But literally.
Yeah, what we eat is made up of these elements.
Right.
and they become part of us.
It's like the food web.
It is.
And like how
it highlights this like cyclical nature of coming to be and passing away.
Right. Everything's like interconnected.
How substances are constantly being like transformed, recycled, flowing from one form to another.
All right. So we've covered a lot of ground here.
We have.
We've explored the debate about change. Right. We've delved into the theories about the elements. We've looked at how Aristotle is like tying it all together with these ideas of matter and contraries.
Yeah. But there's one crucial piece missing.
Okay. What's that?
We've talked about the what of change.
Okay.
But what about the why?
Right. Like,
what sets this whole process in motion?
Yeah. What's the driving force?
That's what we'll pick up next.
Okay. All right. I'm ready. Let's do it. All right. So we've got the ingredients of change, those fundamental elements, and how they mix it up.
Yeah.
With those opposing forces. But you're right. There's this like bigger question.
There is.
Lurking. Like what's the driving force behind it all?
The why.
Yeah. Like why does anything change in the first place?
Yeah. So this is where Aristotle kind of goes from like philosopher-chemist to philosopher-physicist.
Okay.
He wants to connect the eternity of motion with how time flows.
Okay.
And how this relates to this never-ending cycle of coming to be and passing away.
Okay, you've piqued my interest, so lay it on me.
All right.
How does Aristotle explain this why of change?
So he starts by observing that whenever there's like continuity in any process, whether it's something coming into being, undergoing change, or any kind of motion.
Right.
There's this principle of consecutiveness.
Yeah,
so things happen, like one after the other.
Right.
Seamlessly, with no gaps.
Okay, it's like a chain reaction.
It is. Yeah. Like dominoes falling.
Yeah, one event leads to the next.
Precisely.
Okay.
And this leads him to ask, like, this really interesting question.
Okay.
Is there any point in this chain of events where the future is already set in stone?
Okay.
Is there a moment where what's going to happen is absolutely determined? Or is there always like wiggle room, possibility for things to go in a different direction?
Wow, that's like asking if we have free will or if everything is just fated.
Exactly.
Yeah, that's huge.
It is. And Aristotle tackles this question head on.
Right.
Using this concept of necessity.
Okay.
So he distinguishes between things that happen necessarily.
Right.
Meaning they have to occur.
Okay.
Things that are impossible.
Okay.
And things that are contingent.
Contingent, meaning they could go either way.
They could go either way.
So some things are inevitable.
Yeah.
Some things are totally out of the question.
Right.
And some things like up in the air.
Up in the air, yeah.
Okay.
And he applies this framework to the process of coming to be.
Okay.
So for example, he considers whether the solstices, those points in the year when the sun reaches its highest or lowest point in the sky, have to happen.
Okay.
Or if there's a chance they might not.
So he's questioning if there are certain events in the natural world that are like guaranteed?
Absolutely guaranteed. Like, is it necessary that they occur?
Okay.
So he's examining this relationship between cause and effect and whether the necessity of one event, dictates the necessity of another.
Right.
So he asks, like, if you need foundations to build a house, does the existence of foundations guarantee that a house will be built on them?
Well, I mean, it seems logical if you've got the foundation there.
Right.
You're probably going to build a house.
Right. But does it have to happen?
Does it have to happen?
That's the crux of the argument.
Okay.
So Aristotle says the connection between the two is only truly necessary if the house coming into being is itself absolutely necessary. Okay. Meaning it must always be.
So it can't just be a one-time thing.
It can't just be a one-time thing. It has to be
an ongoing cycle.
Part of a continuous process.
Okay.
Yeah. So for Aristotle, what's truly necessary is also eternal.
Right.
And something eternal can't have a beginning or an end.
Okay.
So if a house coming into being is truly necessary, it must be part of this continuous process.
So we're back to cycles again.
We are back to cycles. It's a
This idea of eternal recurrence is like, really?
It's a recurring theme
Yeah.
in Aristotle's philosophy.
Okay.
So this leads him to a crucial conclusion.
All right.
Absolute necessity is only found in cyclical processes.
Okay.
And those things that keep returning upon themselves.
So things like the changing seasons, the cycle of day and night, the waxing and waning of the moon.
Yes. These are all examples of events
Well, those are like
that are truly necessary
guaranteed
and eternal in Aristotle's view.
Right. They keep happening.
They just keep happening.
Okay.
And he argues that this cyclical process of coming to be is ultimately rooted in the eternal circular motion of the heavens.
Okay.
So it's this celestial dance.
It's like a big cosmic clock.
It is. It is like a giant cosmic clock.
With the stars and the planets.
With the movements of the stars and planets driving
those cycles here on Earth.
Exactly. And this cyclical view of time and change helps explain why, even though individual things come and go, the universe as a whole persists.
It's this constant dance of creation and destruction.
It is, with the elements flowing from one form to another, eternally driven by the motion of the cosmos.
Okay, that's a lot to think about.
It is.
But it's a beautiful vision.
It is. And for Aristotle, you know, this revealed the beauty and the order and the underlying coherence of the universe.
It makes me feel simultaneously insignificant.
I know.
But also, like, strangely connected to the vastness of it all.
That's the power of philosophical inquiry.
It is.
It allows us to, like, grapple with these profound questions. Expand our perspective and deepen our understanding of both ourselves and the universe we inhabit.
Yeah, and it's just amazing to think that these ideas were being debated, like, over 2,000 years ago.
With such depth and rigor.
Yeah, it really shows that the human desire to understand the universe
is
timeless. It's,
and universal.
It's a universal endeavor.
It is.
Well, on that note, I think we've reached the end of our deep dive into Aristotle's On Generation and Corruption.
It's been quite a journey.
It has. I know I've learned a ton. I'll be thinking about this for quite a while.
As you should. These are questions that have, like, captivated thinkers for centuries. And their relevance continues.
It does. Absolutely. To our listeners out there, keep those philosophical wheels turning. Keep exploring the world with curiosity and a sense of wonder. You never know what incredible insights
you might uncover.
And remember, even though these ancient Greek philosophers lived in a time without modern science, the questions they wrestled with
about
change, substance,
and the nature of reality
were still profoundly important.
They are.
Keep asking those big questions.
Don't
be afraid to dive deep in search of those answers.
Absolutely.